Hello and welcome. My name is Vakile, and I want to welcome you to this program that I dubbed electrical engineering tidbits. And we're going to be dealing with a lot of engineering in general, engineering things, and engineering subjects, and so forth, and discussions and talk shows. So I want to welcome you to this first one. And this is an introduction to electrical engineering, power systems. Okay, and in this program dubbed electrical engineering power systems, we're going to be dealing with a few things here that will benefit the following people. They will benefit network protection design engineers to help them with their protection designs, equipment specifications and tendering, and adjudications, and protection system reviews in their networks, and settings calculations, and fault level calculations. And it's going to also help them to do some fault diagnostics after they get a fault in the system, and to take mitigatory measures to prevent situations like that from happening again. It's also going to benefit protection commissioning engineers. Protection commissioning engineers are going to grab some points that will help them to commission and test electrical circuits, electrical plants, substations, and power stations. And it will also help them to capture some information that they should document, or to capture the documenting procedures for a commissioning activity, so that that information would be used in the future for references. Okay, and it's going to also help transmission and distribution engineers and technicians. And these guys normally do the system protection. I mean the transmission network, distribution network, and generation network. And these people need a lot of information from protection, because on a day-to-day basis, what happens in the system would eventually be captured by the protection systems, and the security of the system is dependent on protection systems. So these guys are going to gain some information that will help them to maintain and new and old substations in terms of the infrastructure. We'll introduce some infrastructure that they need to be aware of, new protocols, new SCADA systems, and so forth, and new relays. And it will help improve asset management policies for these transmission and distribution engineers. And this will ultimately as well help in the designs of transmission and distribution lines and the network as a whole. And it will help distribution engineers, technicians, and electricians to commission their circuits after they install them. Next up are network generation, transmission and distribution planning engineers. These guys are going to gain a lot from this program, because the job primarily is planning new substations and expanding the network. So the information that I'm going to deliver here is going to help them to make some wise decisions in how they choose to bring up new projects, and how they choose to connect, say, new substations or new stations to the existing ones. Okay, and the next up we have field operations engineers and technicians. These could be communications engineers or SCADA engineers, and could be transmission engineers as well, or maintenance engineers. They're gonna grab a lot of information from this program, because they deal mainly with network configurations, network monitoring, that is SCADA, substation substation monitoring, like substation control systems, or SCADA, which is supervisor control and data acquisition. And this protection program is going to help them to assemble some information to actually monitor and some parameters to control in the system. And so these guys are going to gain communication engineers, SCADA engineers, and operations engineers. In fact, operations engineers are going to gain a lot in how to operate the systems, so that those systems don't they don't produce, like, they don't come up with some difficult outages or some difficult configurations that would be detrimental to the operation of the system. So here we are. We also have network generation engineers and technicians. They're going to gain a lot, because for generation guys, they need to know quite a lot of what is happening in the system from their generation point of view, so that they can plan outages, they can plan when to step up the power, they can plan their day-to-day activities. And it's also gonna the program is gonna benefit project engineers. Substation project engineers would need to know the requirements of protection for them to be able to come up with equipment that is required, to come up with decisions that are required. Take, for example, when you're dealing with a brownfield substation construction, you need to know the outages, you need to know the effects of taking out some feeders or taking out some transformers from a system. So project engineers need to be informed on how those things can be achieved, how taking a line can be achieved. Or they also need to be informed on why they should do certain things in a certain way, or why they should follow some standards, for example. So these are the people. And we also have student engineers and technicians. Students are going to learn, they're going to be motivated by this program, because they're going to dig deeper into the programs, and they're going to find out what really is power systems. So this is the thing. These are the groups that are going to benefit. And next up, we're going to talk about the information that I'm going to discuss in these programs that I'm going to churn out. We're going to discuss documentation in regards to design documents, which are tendering documents, protection design criteria, design standards, and we're going to discuss commissioning documentation. That is commissioning plans, inspection and test plans, tender documents, and check sheets, and safe work method statements. And maintenance documentation is basically going to include things like how you maintain equipment in any substation. Okay. And operations documentations, how you operate the system. It's mainly derived from the way the protection is configured. So we're going to discuss these things so that these become kind of clear. And the other documentation that's going to be discussed is asset management documentation. Okay. Now, coming up here, we're going to also discuss protection equipment. It will go this way. We're going to discuss types of equipment operation theory, and schemes in which the equipment we discuss are going to be applied, or where they are applied, and the testing and commissioning of those types of equipment, and their maintenance routines. And we are also going to discuss general engineering phenomena associated with the equipment in question. Okay, so these are the groups of equipment that we're going to discuss in this program. We're going to discuss protection Primary equipment. Primary equipment. In primary equipment, we're talking about transformers. That is power transformers, auxiliary transformers, earthing transformers, voltage transformers, current transformers, their types and their operation and so forth, and their protection and how they're commissioned. And we're going to discuss circuit breakers, auto disconnectors, isolators and disconnectors, earth switches, surge arresters, and line traps. And we're also going to discuss some substation areas like bus bars and earth wires, the area of earth wires. We're also going to discuss cables. These are power cables and control cables, fiber optic communication cables, and many other cabling we may get in substations. So we're going to discuss all that. And next up, we're going to discuss switchboards. Switchboards are very, very common in sub-transmission and distribution. So we're going to discuss how you deal with switchboards, how you commission them, how you specify them in the first place, and how you commission them. And we're also going to talk about some power compensation, static compensators. And in this, we're going to discuss some reactors, some capacitors, some static VAR compensators. And we're also going to discuss some harmonic filters and some variable speed drives, VSDs. And in this primary equipment section, we're also going to discuss motors and generators and then earthing systems. Okay, so these are the things. And we also have protection secondary equipment. In this section, we're going to discuss protection relays, fault recorders, remote terminal units, communication panels, power line carrier, fiber optic. We're going to discuss the SCADA at large, that kind of stuff. And we move on to protection ancillary equipment. We're going to discuss DC distribution boards, AC distribution boards, battery chargers, batteries, lighting, marshalling boxes, marshalling boxes for transformers or for feeders and reactors and all those bays that you find in substations. And then we also discuss some interconnections. This is sweet. We discuss the voltage selection schemes that are used out there, interlocking schemes that are used out there, DC buses, intertrip buses that are implemented out there. So this is the thing. And we're also going to have some miscellaneous equipment that we are going to discuss. These are things like fencing, and we're going to discuss buildings, trenching in the substation, and so forth. Those things are going to come under miscellaneous, and we're going to discuss them and their importance to the whole substation or to the whole project. Now, next up is protection, our focus, or the focus of our discussion. The focus of our discussion is going to be design. That's number one. Design. That's power systems protection design in terms of schematic drawings, tendering and equipment specification, protection design criteria, protection fault diagnostics, and then protection systems commissioning. That's commissioning documentation, factory acceptance testing, site acceptance testing, and commissioning test equipment. We're going to touch on that as well because it's quite important. And we're also going to discuss power systems maintenance. That's maintenance regimes and fault diagnostics methods. And we're going to discuss power systems project management and power systems operations. So next up, methods. The methods that we're going to use to present this program. These are the methods. We're going to use some hardcore presentations. That's like this one. I'm just talking to you. And you're also going to use some video experience talk shows. So that means I'm going to invite some other experts, and then we discuss certain things in a power system, certain things that affect design or that affect commissioning or project management of a power system. Okay, and we're also going to do some question and answer sessions. Oh, these are going to be interesting, and that's where we will be, interacting with you guys. If you have any questions, you just bring up questions that have to do with protection systems, and then we discuss those here. We find the answers, come up with the answers, and then we discuss them here. And we're also gonna do some how-to series under this topic here. So, how to do something, or how to commission a transformer, how to commission a breaker, how to specify a current transformer. Okay, so those are the topics that are going to come up in the how-to series. And you may ask, what's in it for you? So there will be theory of systems, engineering calculations, engineering reasoning, engineering decision making, and protection scheme designs, test and commissioning methods, and general engineering standards that we'll be talking about, so that you get finished with those things. Thank you very much. My name is Vukile. I'll meet you in the next program where we start discussing the general arrangement of a power system. See you later.